Hey everyone, in this video I'd like to talk about how to write the equations of parallel or perpendicular lines. In these types of problems, we're going to be given some starting information. We're going to be given the equation of a line, and we're going to also be given a point that is not on that line. And what we're going to want to do is we want to write new equations, so the equation of a new line that is either parallel to the original line that goes through our given point, or is perpendicular to the original line and goes through the given point. So I'd like to take a look at an example and just talk through that process and how we do this. So the example I have says write the equation of the line that passes through the point 1, 5, that is A parallel to, and B perpendicular to the line y is equal to 3x minus 5. So I'm actually going to need two new equations here. My first one, I want it to be parallel to y is equal to 3x minus 5, but I want it to go through the point 1, 5. And then my second equation, I want that one to be perpendicular to our given line, but that also goes through the point 1, 5. Now in general, it's important to note that whenever you're writing the equation of a line, you need two pieces of information. You need a slope and you need a point. The point is given to us. It's the point 1, 5. The slope, that second piece, we're going to get that based on whether we want it to be parallel or perpendicular to our given line. So the slope of the given line is 3. So to write the equation of a line that is parallel to that, we want to use the same slope. So for letter A, the parallel line, we're also going to use a slope of 3. And then the point we're going to use is the point that we're given. So we have a slope of 3, and it's going to go through the point 1, 5. So now using these two pieces of information, why don't we write the equation of the line? For letter A, let's use point slope form. So point slope form is y minus y1 is equal to the slope times x minus x1. And then the point we're given, 1, 5, this is going to be our x1, y1. Now we just have to do some substitution. So if we substitute in the y value, we have y minus 5, our slope is 3, and then we have x minus 1. And that's a perfectly fine equation of a line. If we wanted to, we could go further, and I could rewrite this in slope-intercept form. So why don't we do that? So to rewrite it in slope-intercept form, we just need to rearrange it so that we isolate the y value. So we have y minus 5, and I'm going to start by distributing the 3. So 3x minus 3. And then to finish up, we're going to add 5 to both sides. So we end up with y is equal to 3x, and then adding 5, we get plus 2. So here's the line that is parallel to our given line. I know it's parallel because it has the same slope of the line we were given. But now this one goes through the point 1, 5. Now for letter B, for the perpendicular line, I don't want to use the same slope. I want to make sure that this line is perpendicular. So we're going to need to use the opposite reciprocal slope. So instead of using the slope of 3, we're going to flip that. That will give me the reciprocal. And then since the slope is positive, we want to use the negative slope. So that will be the opposite. So instead of positive 3, we have negative 1/3. And then the second piece of information we need to write this line, the point that we want it to go through, is the point 1, 5. We already used point slope form, so why don't we use slope intercept form? Y equals mx plus b. Now when I'm doing this, I need to find the y-intercept. I know the slope, I know an x value, I know a y value that this line is going to go through, but I need to find that y-intercept. So my slope is negative 1/3. This point is going to be my x and my y, and then we can solve for b. So the y value is 5. We have a slope of negative 1/3. And then we're going to multiply that by the x value of 1. And then that just leaves the b variable as the only variable, so we should be able to solve for it. This is just negative 1/3, so we need to add that to both sides. So I could write this as 5 1/3 is equal to my y-intercept. Or if I wanted to write this as an improper fraction, I would get b is equal to 16/3. And now after you find that y-intercept, all we have to do is rewrite the equation of this line. So we have y is equal to, we'll plug in our slope, negative 1/3, and then we'll also plug in this y-intercept. So we have negative 1/3 x plus 16/3. And here's the equation of the line that's perpendicular to the one we were given. I know it's perpendicular because the slopes are opposite reciprocals, but this one will go through the point 1, 5. If we take a look at the graph of this, we have our original line, and then our point 1, 5, which is not on that original line. And then through that point 1, 5, we have our two new equations. We have the one that's parallel, the one that goes, it has the same slope, but now it goes through that point 1, 5. And we also have the one that's perpendicular with the opposite reciprocal slope that also goes through the point 1, 5.